Hi everyone, in this video we will be discussing state functions. We will define what a state function is and relate it to what we've been talking about in terms of energy and enthalpy. Internal energy is a state function, and a state function is something that depends only on the current state. It doesn't depend at all on how we got there. Temperature is another example of a state function. So if we look at these beakers of water, we can relate temperature and internal energy to one another. Temperature is a good indicator of kinetic energy within a system. Something that's hotter will have molecules that are moving much faster, having more kinetic energy. So if we look at the hot beaker, it has a higher amount of internal energy, and when we cool it to 25 degrees Celsius, it would have a lesser amount of internal energy. The other scenario is that the cold beaker, and this has the lowest amount of internal energy of all those shown, and if we warm that to 25 degrees Celsius, we now are at a higher internal energy. Looking at the temperature of these two beakers, both being at 25 degrees Celsius, will have the same internal energy because they're at the same temperature, and temperature is an indicator of kinetic energy in a system. A familiar example of a state function would be altitude. Say you're climbing a mountain. You might have two different ways to get to the top, but your change in altitude is going to be the same regardless of the path that you take. So altitude is an example of a state function. It depends only on your current position. Now, the path or the distance that you take is not a state function because it does depend on the path that you take to get there. Let's highlight how changes in internal energy, or delta E, can be seen as a state function. Let's say we start at some initial energy level, and we undergo some process that gets us to a lower energy state. Energy could be lost exclusively in the form of heat. Let's say we change our conditions and we're still undergoing the same energy difference, but only some of that energy is lost as heat, while the remainder is lost as work done by the system. So you can see that here delta E is equal to Q, and here delta E is equal to Q plus W, but in both cases we've gone the same delta E. So delta E will be the same regardless of the path that it took to get there. One reason we care is because of chemical reactions. Often there are multiple pathways that we could get from reactants to products in a given reaction. So take, for example, the one shown here. We have reactants to products, and both path A and path B result in the same overall change in energy, highlighting again the fact that delta E is a state function. It doesn't matter on the path that it takes to get there. However, path A requires significantly more energy to get this reaction going compared to B. And so this will have significant implications on things like the reaction rate and could even influence your yield of product. So we can actually exploit this by using catalysts. And enzymes, you might have heard of, they're biological catalysts that would proceed by a lower energy pathway, increasing the rate and forming product more favorably. Now we know what a state function is. It's something that is dependent only on the current state. It is not related to the path that it took to get to that final state. We'll be using state functions frequently in the course, so keep that definition in the back of your mind. Some state functions that we'll encounter are energy, enthalpy, temperature, and pressure. So, and when you see those, you want to be thinking state function. Thanks for watching.